Hello everyone, welcome back to our RFID Kit for Arduino tutorial series. Today we're gonna meet a new device, a photoresistor. Have you ever seen one in your life? I bet you may do, though unconsciously. Okay, now let me give you some details about it. Here are some scenarios. The street lamps light up only when it's dim on the street. Or so, lamps in the corridor are only lit up when there's sound at night. In the daytime, whenever we talk, they will not light up. That's what photoresistor does. It is a light-controlled variable resistor. The resistance of a photoresistor decreases with increasing incident light intensity. That is to say, it exhibits photoconductivity. In this experiment, we will test whether the resistance of the photoresistor will decrease with its stronger incident light. So let's get started. First, let's look at the experimental phenomena. Under a certain lighting condition, some LEDs light up. When it gets brighter, all the LEDs are on. Place the photoresistor in complete dark, and all the LEDs go out. Now let's see what we'll need for the experiment. A breadboard, the SunFounder Uno board, a USB cable, some drummer wires, 8 LEDs, 8 resistors of 220 ohms, a 10K resistor, and a photoresistor which we'll start to apply today. Okay, the experimental principle is, when the light increases, the resistance of the photoresistor decreases. Thus, the voltage of the A0 port gets higher. Then the AD converter converts the voltage, which is a continuous physical quantity, into digital value. The value determines the number of lit LEDs, which means the greater the value gets, the more LEDs will light up. When it gets bright enough, all the LEDs light up. When it is completely dark, all the LEDs go out. Okay, now let's build the circuit. It will not be fairly easy or too difficult though, so please pay attention to the following steps. Hook up the 8 LEDs to the breadboard and connect their cathode together. Then connect them to the GND of the SunFounder Uno board. Hook a 220 ohm resistor up to the anode of each LED. Then the first LED goes to pin 5 of the Uno board, second to pin 6, and the same to all the other LEDs till the last LED goes to pin 12. Next, hook up the photoresistor with a 10K resistor and then connect them to A0 of the SunFounder Uno board. In the end, wire the photoresistor to 5 volts and connect the other terminal of the 10K resistor to ground. Okay, so the circuit is finished now. Let's move on to the coding part. Open IDE. The constant integer means the variable is an integer, and NPR LEDs means there are 8 LEDs in total. Then write another constant integer variable to connect the 8 LEDs to pin 5 to 12 respectively. LED pins is an array. It contains 8 parameters from 5 to 12, indicating pin 5 to 12. Then connect photo cell pin to A0. The variable sensor value is to store the resistance of the photoresistor. It is 0 by default. The variable is to store the number of lit LEDs and is also 0 by default. Since NBR LEDs equals 8 when LED equals 0, from which we can easily see 0 is smaller than 8, LED++ equals 1. Then run the following code. Set the first LED as output with the function pin mode, which we already learned in the previous lessons. So in the same way, when LED equals 1, because 1 is smaller than 8, LED++ equals 2. Then run the same code and set the second LED as output. It repeats 8 times till all the LEDs are set as output. The fourth statement is to repeat the statements in the bracket. Read the value from photocell pin to sensor value for the use of the following function. The basic form of a map function is map value from high to low to high. It remaps a number from one range to another. That is, a value from low would be mapped to too low, a value from high to too high. In this case, for a sensor value which is read from photocell pin, as mentioned above, map 300 to 0 and 1023 to NBR LEDs, which is 810. We set 300 here according to the reading for the photoresistor. Now let's do some mathematics. The range between 300 and 1023 can be divided into 8 parts, and each one is 90. Suppose the value read from photocell pin is 480. Then the gap between 300 and 480 is 180, which is 2 parts. So the result of the map function is 2. Thus, LED level equals 2. The value of LED level is 0 to 8, is from the map function as mentioned above. When LED is smaller than LED level, run the following code. Set LED pins square bracket LED as high, namely lighting up the LEDs accordingly. For example, if LED is 1, LED pins bracket LED will be 5, 6, which means the first 2 LEDs will light up. Otherwise, run this code. Set LED pins square bracket LED as low to turn off the LEDs. Okay, the code part is finished. Now connect the SunFounder Uno board with the computer and download the program. Let's check the results. Now, under such a lighting condition, some LEDs light up. When it gets brighter, or the LEDs are on, then cover the photoresistor all up and we can see all the LEDs go out. Okay, let me wrap it up. In this experiment, we learned that the resistance of the photoresistor decreases with increasing incident light. It is useful practice, actually. You can apply it in daily life conveniently, like change the bulb in your room into a light-controlled or voice-activated one. so you can just make a sound to turn on the light and avoid knocking something when groping around in the dark for the switch. Another advantage is, even if you forget to turn off the light, without sound it will be off automatically, which is convenient and power saving. Also, with the light control setting, it won't light up in the daytime. I think this is really cool and hope you enjoy it. You may try to make something fun. For any questions, visit our website www.7founder.com and leave your message. Thanks for watching. See you!